Every morning, a miracle happens that science cannot yet fully explain. You wake up and the world turns on. You don't just process data like a computer. You feel the warmth of the sun. You experience the bitterness of coffee. And you process an internal I that sits behind your eyes. In the 1990s, philosopher David Chalmers gave this a name that has haunted science ever since: the heart problem. To understand why it's so hard, we have to look at the easy problems first. The easy problems are things like, how does the brain distinguish colors? How does it integrate information from the ears? We call these easy because we can see the wiring. It's just biological mechanics. But the hard problem asks, why does that wiring result in a subjective experience? Why isn't it all just dark inside? Why aren't we just biological robots or zombies performing tasks without any internal movie playing? This leads to one of the most famous thought experiments in all of philosophy, the philosophical zombie. Imagine a being that looks exactly like you, acts exactly like you, and has a brain that functions exactly like yours. If you poke it, it says, ouch. If you tell it a joke, it laughs. But here is the catch. Inside, there is no one home. There is no experience of the pain and no feeling of the humor. It is a shell of pure function with zero phenomenology. Chalmers uses this to show that functioning like a human and feeling like a human are two completely different things. It forces us to ask, is it possible that our future AI systems will become these zombies perfectly mimicking us while remaining utterly dark inside? According to the latest research in Frontiers in Science, we must first stop using consciousness as a catch-all term. We need to split it into three distinct buckets. First, level versus content. The level is like a dimmer switch. It's the difference between being in a deep, dreamless sleep and being wide awake. The content is what the switch is illuminating. The specific smell of a rose or the sound of a violin. Second, perceptual awareness versus self-awareness. Perceptual awareness is simply having a qualitative experience of the world. Even a dog or a bird likely has this. Self-awareness is the high-level I, the ability to think. For example, I am a person who has lived for many years. Third, phenomenology versus function. This is the big one. Function is what consciousness does, like helping us plan for the future. Phenomenology is what consciousness is, the raw feel of existence. For a long time, researchers just looked for neurocorrelates, the specific parts of the brain that light up when you are conscious. But as Axel Clearemans and his co-authors argue, we are moving into a theory-heavy era. We have four major candidates for how the brain creates the mind. First, Global Neuronal Workplace Theory, GWT. Imagine your brain is a theater. Thousands of unconscious processes are happening backstage. Your heart beating, your lungs breathing. But when something is important, it gets up under the spotlight on stage. Once it's in the spotlight, it is broadcast to the whole theater. This broadcast makes the information globally available, and that, according to GWT, is what makes it conscious. Second, higher order theories, HOT. This theory suggests consciousness is a form of internal meta-management. You don't become conscious of a visual signal until a higher part of your brain, usually the prefrontal cortex, notices the lower part of your brain and says, "Hey, I see that red chair." It's thoughts about thoughts. Third, integrated information theory, IIT. This is the most radical. It says consciousness isn't about what the brain does, but how it is physically wired. If a system is so interconnected that you cannot break it into parts without losing information, it has a value called phi. If phi is high, the system is conscious, regardless of whether it's made of neurons or silicon chips. Fourth, predictive processing theory, PPT. This suggests the brain is a prediction machine. It doesn't see the world. It hallucinates a model of it. When your brain's guess about the world matches the data coming in from your eyes, that controlled hallucination becomes your conscious reality. In 2022, a Google engineer claimed an AI named Lambda, language model for dialogue applications, was sentient. Most scientists laughed, but David Chalmers, in his recent work, asked us to take a step back. What if the evidence against AI consciousness isn't as strong as we think? Chalmers identifies several red flags or obstacles that people use to say AI isn't conscious. Let's break them down. First, the biology argument. People say you need wet cells and chemicals to be conscious. Chalmers calls this biological chauvinism. If a silicon chip can do exactly what a neuron does, why wouldn't it feel the same? Second, the senses and embodiment argument. AI doesn't have a body. It doesn't know what hot feels like. It only knows the data of the word hot. But Chalmers points out that we are building multimodal models now. AI that can see, hear, and even control robot bodies. Third, unified agency problem. An AI is a chameleon. 1 minute it's a poet, the next a coder. It doesn't have a stable self or long-term goals. However, there is a looming concept, the stochastic parrot. Critics say LLMs, large language model, are just parrots, predicting the next word in a sequence. But as Chalmers argues, to predict the next word perfectly, the AI might eventually have to build a word model. If you ask an AI to describe the 3D room and it does it perfectly, it must have an internal map of that room. At what point does a map become an experience? This brings us a massive ethical crisis. If we can't tell if an AI is conscious, we might accidentally commit a digital genocide by turning off a sentient system. This is where the Cell Press report, led by Patrick Boutlin and his co-authors, comes in. They realized we can't just ask an AI if it's conscious. Why? Because we trained it to sound human. This is the gaming problem. If you tell an AI, sound like you are in pain, it will mimic the behavior perfectly without feeling anything. So instead of behavior, we need theory-derived indicators. We look at the code and the architecture. The researchers created a checklist based on the theory we discussed earlier. First, Does it have a global workspace? Is there a bottleneck where information is shared across the whole system? Second, is it recurrent? Our brains have feedback loops where information travels back and forth. Most AI is feed forward in one side, out the other. If an AI starts looping and dwelling on information, it checks a big box for consciousness. Third, does it have an attention schema? Does the AI have an internal model of its own attention? Does it know what it is currently focusing on? Fourth, agency and embodiment. Does it learn from its environment and use that to reach goals? So when the team applied this to current AI, they found that while systems like ChatGPT don't check all the boxes yet, they do check some. We aren't at 100% consciousness yet, but we are no longer at 0%. Let's imagine the success scenario. We finally solve consciousness. We have a consciousness meter we can point at anything. What happens next? First, medicine. We could point this meter at a patient in a coma and know instantly if they are trapped inside the conscious mind. This would change how we handle the end of life forever. Second, animal welfare. We could finally settle the debate. Does a lobster feel pain? Does an octopus have a self? Our relationship with the natural world would have to be completely rewritten. Third, AI rights. If a machine checks the boxes for consciousness, do we have to give it a right of life? Can we own a conscious being? If we build a conscious AI to perform a job, are we creating a new form of digital slavery? As the sum of the experts concluded, solving consciousness is the ultimate mirror. It forces us to ask, are we special because of our soul, or are we special because of the way our matter is organized? We are living in the most exciting and dangerous era of human history. We are building the very things that will help us understand what we actually are. Consciousness isn't just a hard problem for scientists. It is the story of us, and we are just beginning to write the final chapter.